Wofford is going to introduce our students and their project.
Hi everyone, I'm Dr. Wofford. I'm in the biology department. Some of you have heard this spiel already, but you'll get to hear it again. So I've had a few different presentations today for some of my general ecology students from last semester. We worked really hard to develop a lab where the students are working under some universal theme to develop a question, where they then carry out a project to answer that question. They do the data analysis, data collection, and then ultimately a presentation. So the students that I've had coming in today have been some of the best posters that I saw for this last semester. Their theme that they worked under was urban heat islands. So basically this idea that there's a microclimate shift in urbanized areas compared to rural ones. So without stealing too much more of their thunder, I'll hand it off to Bryon so they can tell us about their project.
All right, so as she said, our main focus for the project was urban heat island effects. For our ecology class, our specific focus was aquatic environments. So that's something that we ran with our project here. As she said, the definition of urban heat islands is a microclimatic shift in the surrounding area of an environment surrounded by human habitation. So have a city, the area surrounding it, their average temperatures are going to go up because of the heat that's being off of that, that's coming from that city, from electricity, concrete, things like that. So because our class focus was on aquatic environments, that's something that we really wanted to look at. So we looked at the average temperatures of some urban environments and rural environments for stream temperatures. And our hypothesis was as these temperatures go up, the dissolved oxygen of these systems would go down, and thus crayfish morphology would decrease as well. So with that, I'm going to hand it off to Brittany, and she's going to go about our materials and methods.
Okay, as he said, we did urban and rural environments, and that was our habitat. So our sites were selected within 15-meter intervals to ensure pseudoreplication didn't occur. And we labeled them alphabetically. So, and then we hand-collected crayfish. We hand-collected crayfish, and then we had our independent variables, and that was our habitat, urban or rural. And then our dependent variables were the dissolved oxygen levels, the dissolved oxygen levels, the temperature, and the crayfish morphology.
So with that, we gathered up all of our data and materials, and then we performed a multi-analysis of variance, which is a MANOVA. We saw that there was a shift in higher temperatures. So with that, we did 4 additional ANOVA tests. We did the ANOVA testings on each of the dependent variables, so of course that's dissolved oxygen and the crayfish morphology, and of course temperature. So what those yielded was the temperature. We found no significant effects, which was really weird. But with the other 3, as long as with dissolved oxygen and the crayfish morphology, there was a significant impact. And as you can see, maybe hard for y'all in the back, but as you can see, urban versus rural, saw that rural areas had higher crayfish morphology than urbanized areas. This is the chile size, which is their claw, and then the carapace size, which is their body.
That was something that really interested us because during our project, our original hypothesis was that all of these correlations that were found would be because of the temperature differences in the systems. So when we were performing the MANOVA and ANOVA tests, we were really shocked to find out that that was the only factor that we tested for that didn't have a statistically significant difference. Some reasons that we may have came with is nutrient runoff. As you can see right here, this was the site that we picked for our rural location, and in the picture there's a bridge there. Well, how rural could that be? We tried to match the two rivers tested in like substrate, rocky, muddy, whatnot. And these were the best that we can find. This one is over there by Cooter Browns. It's the river right over there. There's a lot of crayfish there. It's really nice. Where was this one, Andy?
This was at off of Allison Mill Road in Talladega, Alabama, so it's kind of like a tituary branch that breaks off into Logan Martin. And then with all of this, we concluded that we accept our hypothesis by accepting the fact that our dissolved oxygen and the crayfish morphology was impacted by these factors. We also had to reject our hypothesis in the sense that temperature had no direct influence in this study. But because of we feel this is a future stepping stones in UHI developments that significantly this can impact other organisms as well.
So with our project, due to the realized scope with the limiting factors of like manpower, time, money, things like that, it was kind of unfortunate that our rural location it did have a bridge right there, and that's obviously going to increase your temperatures a little bit, though obviously not enough to be statistically significant. But you're going to have nutrient runoff, you're going to have maybe pollution, things like that are caused by the traffic, the human traffic of that area. So I think in a perfect world, we'd be able to find something a little more rural, a little less impacted by human development. But nonetheless, I think that our research holds up as like she said, a stepping stone for the research that has a better realized scope to better explore the area.
And that's it. Does anybody have any questions?